It was designed but not to build a moisture sensor, very much like the homework problem we had recently. This one, however, the resistance of the moisture sensor was allowed to be in the range of 100 to 1,000 ohms when it's wet, and infinity when it's dry. So it was possible to do this with just one stage of gain. So the main thing here is to think about we're doing this with a single 9-volt battery, and that could be confusing with regard to where ground is. Ground is really an arbitrary construct, so I can just make my life simple and make this seem like things we're familiar with by connecting ground to that point there. Then it looks familiar. The 9-volt rail now is established by that 9-volt battery. So here is the moisture sensor. When it has 9 volts across it from here to here, it's not quite 9 volts because this voltage with respect to ground is really plus 0.6. So the voltage across the moisture sensor is really only 8.4. But when that happens, we've got 8.4 volts divided by, at worst, 1,000 ohms, so 8.4 milliamps. And 8.4 milliamps times the gain of any transistor is going to be plenty more than 50 milliamps. That's the current that the alarm expects. So this transistor will definitely be saturated. The voltage from here to here is going to be 0, or maybe more accurately 0.2, or whatever VCE sat of this transistor is. And almost all of the 9 volts is going to appear between this point, the 9-volt rail, and this point, which is now only at about 0.2 volts. So the alarm will be nice and loud.